Welcome back again, Advanced Functions, Polynomial Functions chapter. In this lesson number 7, we're going to focus factoring, specifically a sum or difference of cubes. So what is a difference of cubes? So it's a similar idea of difference of square, where it's a squared minus b squared. So if I have to square root, it will be a minus b and a plus b. So that is the most factor form. On the other hand, we have a difference of cube. So if it's a minus b, so you write it first, and then you do a squared plus ab plus b squared. So that is the most factor form. You can't factor anything further than that. So try to memorize the formula, and then we're going to apply it. So question number 1, use the difference of cubes identity to factor this polynomial functions. So as you can see, let's rewrite this again. So a cubed minus b cubed is equal to a minus b, and then a squared plus ab plus b squared. So then we can rewrite it in terms of single term. I can rewrite this as x cubic minus 2 cubic, right? Then I could apply this term x and 2 into the formula. So it will be, because it's different, so it's x minus 2. And then it's a squared, so which is x squared. And then plus ab, which is x and 2. So plus 2x and b squared, which is 2 squared plus 4. And that is the most factor form for x cubed minus 8. Let's try the next one. Again, identify if you can cubic root each term. So in this case, it will be 3x cubed minus cubic root of 64 will be 4 cubed. And then, so without looking, let's practice. So it's going to be 3x minus 4, which is ab. And then bracket, so 3x squared, which is 9x squared. And then times ab, which is negative, negative. So plus 12x plus 4 squared, 16. And that is my complete factored form for this difference of cubes. Now, there is another scenario where it's sum of cubes. We learned earlier that you cannot factor a sum of square. It's impossible. But on the other hand, if you have a cube with sum, then you can factor with a plus b. And the only formula that's different, it's plus now following the cube, but it will be negative ab. Okay, so try to memorize the formula. So use the sum cube identity to factor this polynomial. Let's rewrite the formula, the sum of cubes. So a cubed plus b cubed could be factored with a plus b, and then a squared. Now this time it's going to be minus ab, and then plus b squared. We can rewrite this using a cube plus 1 cube. Then using this formula, let's plug in a plus 1, and then a squared, which is x squared, plus, and then it's going to be negative x, then plus 1. 1 squared is 1. And that is the most factor form of a sum of cubes. Okay, so let's try this again. So again, let's see if I can cubic root each term and its sum here. It will be 2x cubic plus 3 cubic. So I can do the sum of cubes. Now, if any case that you cannot do a cubic, you cannot integrate 27 or any other number with in terms of exponent 3, then you will not be able to do a sum of cubes. So without looking, let's try to remember the formula. It's going to be 2x, a plus b, which is 3, a squared, which is 4x squared, minus ab, so 6x, and b squared, 3, it's 9. And that is my most factor form. Now let's do a little bit of challenge. Now the question is factor completely. So we could, in the previous lesson, we could do a factor theorem or a like integral numbers, but question 3, factor completely. So there's two ways to do it. You could identify if it's like a difference of square or a difference of cube, or another way to do like what we learned in previous lesson, find the integer, which is -16, and do a factor theorem to equal to 0. But rather than doing that, you will know right away that it's two terms and it's minus, and both of them, it looks like I could do a difference of square. It's like a squared minus b squared. As long as the square is an even number, you could apply the difference of square scenario. So in this case, I will be square rooting x4, so it's x squared minus 4, right? Square root of 16 is 4, and then x squared plus 4. And then you look further and see if you can factor. Yes, over here, it's again a difference of square. They're perfect square with minus. But unfortunately, the second one, it's not factorable because it's plus and it's an even number exponent. So I'll be factoring it. X minus 2, x plus 2 for the first bracket, and then I just bring it down. X squared plus 4. And that will be the most factor form. And lastly, we have x5 plus 1. It doesn't follow any trend because it's plus and it's not x cubic. Instead, it's odd number. So if you have exponent that is an odd natural number, then the following rule will apply. So for example, if a to the n plus b to the n, then if I want to factor, it's going to be a plus b, and then it's going to be a n minus 1, and then minus a n minus 2 times b, and then it will be plus this time a n minus 3 b squared, and plus a 2bn minus 3, and so on. Okay, so that's the pattern that you will follow. So in this case, it's going to be x plus 1, and then you're going to subtract the first term, so it's going to be x to the 4 minus x to the 3 times 1, which is itself, and then plus minus 3, so it's going to be x squared times 1, and then minus, so it should be minus, sorry, you interchange, x to the 4 minus, so it's going to be x to the 1 minus 1 squared, it's 1, and then lastly, x to minus 4 is 0, and then it's going to be just b itself, plus 1. Okay, so this is a special type of a factoring where you just have to memorize the pattern if n is a natural odd number.